Hello, welcome to all. In the previous class, we have seen what is measurement and what is the instrument and what is measurand. So, measurement is the process by which we can convert a physical quantity into a numerical number. How can we convert the physical quantity into a numerical number? It's by the process of comparing the predefined standard with the unknown value. Next, we have seen what is instrument. The device which is used for finding the magnitude of that physical quantity is called as instrument. Next, what is measurand? So, measure is nothing but the physical or the chemical or electrical quantity which is to be measured is called as measurand. Next, we have seen what are all the physical quantities. The quantities which can be measured directly are called as physical quantities, and the various classification of physical quantities like fundamental quantities, derived quantities and supplementary quantities. And we have seen the units which are used to describe the quantities like fundamental units, derived units and supplementary units. And also we have seen the formula which is used to represent the physical quantities in terms of the fundamental quantities is called as dimensional formula. So, what is measurement? Measurement is a process by which we can convert the physical quantity into a numerical value. In this class, we are going to see how to represent the generalized block diagram for a measuring instrument. Let us see the generalized measurement system and its functional elements. So, generally all the measuring systems can be represented with the help of a block diagram. So, we can represent the measuring system with the help of a block diagram, where this block diagram indicates the necessary elements used for the instruments and their functions. So, the block diagram indicates the necessary elements and their functions. So, you can able to study the entire operation of the instrument in terms of the functional elements of the instrument. Now, let us see the block diagram for the measurement system. So, in the block diagram, the first element will be the primary sensing element. So, we have to measure a quantity. So, the quantity to be measured will be given to the primary sensing element first, or we can say that the measurand is the unknown quantity which is to be measured will be given to this primary sensing element. So, what is the primary sensing element and its function? So, primary sensing element is nothing but the element which makes first contact with the quantity to be measured is called as primary sensing element. So, the primary sensing element makes first contact with the measurand or the quantity which is to be measured, or the quantity which to be measured will be first sensed or detected with the help of this primary sensing element. In most cases, the primary sensing element will be the sensors which is used to sense the physical quantities which is to be measured. So, following the sensor, there will be a transducer in most cases in the primary sensing element. What is transducer? We know that the transducer is a device which converts one form of signal into another form. In case of electrical and electronic measurement, this transducer will convert any physical quantity into a analog electrical signal. So, the first stage of the measuring instrument is the primary sensing element, which makes the first contact with the quantity to be measured. This primary sensing element will have a sensors which is used to sense the quantity which is to be measured. Following the sensor, there will be transducer which converts the physical quantity to be measured into another form. In case of electrical and electronic measurement, it will be a transducer which converts the physical quantity into an electrical signal. So, this stage is called as transduction stage. First stage is called as transduction stage, which uses transducers which converts the physical quantity to be measured into another form. The second stage is called as variable conversion element. The second stage of the measuring instrument is the variable conversion element. Let us see what is variable conversion element. So, the output of the primary sensing element may be a analog electrical quantity, or it may be a quantity of any other form. For example, if the measurement system is a digital instrument, so we have to present the output in the form of digital signal. So, the output of the primary sensing element may be a analog sense element. The output of the primary sensing element may be a analog signal. So, in order to convert that analog signal into a digital signal, we need this variable conversion element in case of digital instruments. So, in case of digital instruments, we need A to D converter in order to convert the analog signal into electrical signal. That is, example, in case of digital system, if the output of the primary sensing element is an analog signal, we have to convert that analog signal into a digital signal in order to present the output of the data. For that purpose, we need this variable conversion element, which uses A to D converter, which converts the analog signal into the electrical signal. But while converting this analog into digital signal, the original nature of the signal must be preserved. Only it must be converted into another form, retaining its original nature of the signal. So, not all instruments need this variable conversion element. This variable conversion element is not necessary for all the instruments. In case of any conversion is needed, we can use this variable conversion element. The next element is the variable manipulation element. Let us see what is variable manipulation element. So, the main function of this variable manipulation element is to manipulate the signal, preserving its original nature. So, the meaning of manipulation is, what is manipulation is change in the numerical value of the signal. By retaining the original nature of the signal, only the numerical value or the magnitude of the signal is manipulated with the help of this variable manipulation element, because the output of the variable conversion element may not be sufficient in order to drive it to the next stage. So, we need to amplify the signal in order to drive it to the next stage. For that purpose, we are requiring this variable manipulation element, which will amplify the output of the variable conversion element. So, the example for variable conversion element is amplifier. So, if the output of the variable conversion element is very weak, means we have to convert into a higher signal. So, for that purpose you are using amplifiers. If the output of the previous stage is very high, means it needs to be lowered. So, in that case we can use attenuators. So, based on the measurement system, we can use either manipulation devices like amplifiers and attenuators in order to either increase or lower the level of signals in order to move it to the next stage. Sometimes the output of these transducer, that is primary sensing element, may be combined with unwanted signals like noises. So, it has to be processed. So, that process can be done with the help of this variable manipulation element, that is the process like modulation, clipping, clamping of the signals can be done if in case of noise is combined with the signals in order to get pure and acceptable signal. So, this stage will condition the signal into a pure acceptable form. So, this variable conversion element along with this variable manipulation element together is called as signal conditioning or data conditioning element. So, variable conversion along with manipulation element is called as signal conditioning or data conditioning element. The next stage of the measurement system is the data transmission element, and finally the last element will be the data presentation element. So, why we need this data transmission element is, if the two elements are not interconnected with each other, we need a data transmission element in order to transfer the signal from the variable manipulation element to the data presentation element. So, for that purpose we are using data transmission element. Finally, the data which is to be measured or the quantity which is to be measured will be presented with the help of this data presentation element. In between this, we can also add data storage element if we need to store the data. Let us see the function of this data transmission and data presentation element. Next is the data transmission element. If the elements of the system are physically separated, it is necessary to transmit the data from one element to other element, that is from one stage to another stage. So, there is a necessity for data transmission element. So, the signal conditioning element, that is variable conversion plus variable manipulation along with this data transmission is called as the intermediate stage of measurement. primary sensing element is called as the transduction stage, that is initial stage. The signal conditioning with variable manipulation and variable conversion element along with the data transmission element acts as the intermediate stage of measurement. Next is data presentation element. What is data transmission element? Next is what is data presentation element. So, from the data transmission element, the data will be stored or the data will be transmitted from the variable manipulation element to the data presentation element, where the information which is to be transferred or converted to the person handling the instrument or it must be given to the system used for monitoring and control. So, the data presentation element will convey the information which is to be transferred to the person handling the instrument or the system which is used for monitoring and control. If this data presentation element is used for monitoring the data or the quantity which is to be measured, and then we can use any visual display devices. So, visual display devices may be used for monitoring, or else we can use for recording and analysis purpose. We can use magnetic tapes, recorders, high speed cameras, etc. For recording purpose, we can use magnetic tapes, recorders or high speed cameras. For monitoring purpose, we can use any visual display devices, and for control and analysis purpose, we can use microprocessor and computers. So, microprocessor and computers are used for control and analysis purposes. So, this stage is called as terminating stage, which is the last stage where the quantity to be measured will be presented. Now, let us see the example for this. Let us see the example for the functional elements of a instrument. Now, I am considering the analog ammeter which is used to measure current. Now, let me explain the working of an analog ammeter. So, the analog ammeter will be having a permanent magnet. So, in between the permanent magnet there will be a iron core over which the moving coil will be wound. The moving coil will be suspended with the help of a spindle which will be free to rotate in between this permanent magnet, and there will be a pointer arrangement which will be connected to the spindle where this moving coil is attached, and this pointer will move over the graduated scale. So, this one is the moving coil and core. There will be a permanent magnetic field produced by this permanent magnet. Let us see the working of this analog ammeter. What happens? The current which is to be measured will first flow through this moving coil. So, this moving coil is placed in a permanent magnet which produces the necessary magnetic field. Now, we know that when a current carrying coil is placed in the magnetic field of the magnet, what happens? It will experience a force. This force will make the moving coil to rotate. What happens now? This moving coil rotates freely with the help of the spindle in the magnetic field of permanent magnet. When the moving coil rotates, which is connected to the spindle, the pointer which is also connected to the spindle also moves over this graduated scale. So, this pointer moves over the scale which indicates the amount of current flowing through this coil. So, the deflection of the pointer will be proportional to the amount of current flowing through this coil. Now, let us see the block diagram for this analog ammeter. How to draw the generalized block diagram for this analog ammeter. So, what will be the first element in case of analog ammeter? In case of analog ammeter, the measurand or the quantity which is to be measured is current. So, we have to measure current. So, this current will be given to the first element in the instrument. So, what will be the first element which senses or which will make first contact with the current which is to be measured in case of ammeter? The coil. So, the current first flows through this moving coil. So, the primary sensing element in case of analog ammeter will be the moving coil, which makes the first contact with the current which is to be measured. What this moving coil do? It senses the current to be measured. It senses the current which is to be measured. So, this acts as the primary sensing element. Then what will be the second element? We know that first the current flows through this coil. This coil is placed in the magnetic field of this magnet, where this moving coil will experience a force and will rotate in the magnetic field. So, what happens now? The current which is flowing through the coil is converted into a force which makes the coil to rotate in the magnetic field of the magnet. Now, what happens? The current in the coil is converted into force. So, there is a conversion of this quantity takes place. So, the second element will be the data conditioning element. So, the data conditioning element in moving in the ammeter will be magnets and other components will act as a data conditioning element. What will do this? It will convert current into force. So, the current is converted into force with the help of this data conditioning element, which is nothing but the magnets and other components in the instrument. So, now the current is converted into force. Next, what will be the element? Because of the force, the coil rotates, which is connected to the spindle. Now, I have to view the current which is to be measured over this scale with the help of the deflection of the pointer. How the pointer deflects now? The force which is produced in this coil will be transmitted to this pointer with the help of this spindle. How? The moving coil rotates. Along with the moving coil, the spindle also rotates. Along with the spindle, the pointer also moves. So, the force in the coil will be transmitted to the pointer with the help of this spindle, which acts as a mechanical linkage between the coil and the pointer. So, the next element will be the data transmission element. So, here the data transmission element will be the mechanical linkage with pointer. It is nothing but the spindle which is connected with the coil and the pointer. That mechanical linkage acts as a data transmission element which transfers the force to the pointer. What happens now? This force transmitted to the pointer makes the pointer to move in the graduated scale. So, we can view the or we can present the data which is sensed or measured. So, the next element will be the data presentation element. So, the data presentation element will be nothing but pointer and scale. So, the pointer along with the scale acts as the data presentation element which will present or it will indicate the amount of current which is to be measured. So, this is an example for generalized block diagram for an analog ammeter, where the primary sensing element is the moving coil which senses the current which is to be measured. Then sensed current is conditioned with the help of the magnets and its magnetic field, where the current will be converted into force with the help of this data conditioning element. Again, the force which is to be presented, that is equal to the amount of current, will be transmitted through the presentation element which is pointer through a mechanical linkage along with the pointer. So, that acts as a data transmission element, and finally the data is presented with the help of the pointer and the scale. So, it acts as a data presentation element. So, this is an example for generalized block diagram of an analog ammeter. Now, let us see the another example for an functional elements of an instrument. I am going to take a pressure gauge. So, let us first discuss the working of a pressure gauge. So, the pressure gauge will be having a board on tube. One end of the tube will be closed and it will be connected to a mechanical linkage, where it will be connected to a sector. The sector will be connected to a gearing mechanism which will be connected to a pointer which moves over the scale. So, the input pressure will be given here. This one is the board on tube mechanical linkage which links the board on tube with this sector. This pinion gearing arrangement will be connected to the sector and the pointer which moves over the scale. Now, this pressure gauge which is used to measure the pressure, the input will be given to one end of the board on tube. The pressure will pass through the tube. One end of the board on tube will be closed. So, what happens now? Due to the pressure, the closed end of this board on tube will be displaced through some distance. So, because of the displacement of the board on tube, what happens? This mechanical linkage moves, which in turn connected to this gearing mechanism. So, what this gearing mechanism will do? It will convert the displacement of this tube through mechanical linkage into a deflection, so that the pointer which is attached to this gearing mechanism will show the pressure which is to be measured. Now, let us draw the generalized block diagram for this pressure gauge. What will be the quantity which is to be measured in case of pressure gauge? So, we are having the input pressure which is the measurand which is to be measured. This will be the first quantity which will be connected to the primary sensing element. Then what happens? Due to the pressure at the closed end of the board tube, the pressure is converted into force. So, the pressure is converted into force at the closed end of this board on tube. So, the board on tube acts as the primary sensing element. When the pressure is converted into force at the closed end of the board on tube, what happens? The pressure is converted into a force. So, for that we need variable conversion element. So, this variable conversion element will convert the force at the closed end of the board on tube into a displacement with the help of the movement of this mechanical linkage. So, what happens now? The force is converted into displacement with the help of variable conversion element. So, primary sensing element along with variable conversion element will be the board on tube. So, the pressure in the tube will be converted into force, which in turn converted into a mechanical displacement. So, due to the pressure or force, this mechanical linkage will move, which in turn connected to a sector along with the gearing mechanism. What happens now? This displacement is transmitted to the variable manipulation element. So, the next element in pressure gauge will be the data transmission element. So, which acts as a data transmission element here? The mechanical linkage which is connected in between the closed end of the tube and the sector acts as the data transmission element, which transmits the displacement. Next, what happens? This displacement will be manipulated with the help of this gearing mechanism, which in turn connected to the pointer and shows the pressure which is to be measured. So, the next element will be the variable manipulation element. So, here the variable manipulation element will be the gearing arrangement. What this gearing arrangement will do? It will amplify the small displacement of the mechanical linkage and make the pointer to rotate through large angle. It will make the pointer rotate through a large angle. This will be done with the help of this gearing mechanism, which acts as a variable manipulation element. That is, it is amplifying the small displacement into a large angle. So, next element will be the data presentation element. So, here we know that the pointer will show the quantity which is to be measured over the scale. So, the data presentation element will be the pointer and dial, which shows the quantity which is to be measured, which is nothing but the pressure. It's clear? So, from this block diagram we can say that the variable conversion element and variable manipulation element are needed for this pressure gauge, and also it is not necessary that variable manipulation element should follow after variable conversion element. So, depending on the quantity to be measured and the instrument, the elements may vary in their positions. So, initially the primary sensing element senses the input pressure in the board-on tube and it converts into a force at the closed end of the tube, and this force will be converted into displacement at the closed end of the board-on tube. Next, the displacement makes this mechanical linkage to move. So, the data transmission element will be the displacement of the board-on tube with the help of this mechanical linkage. And the next element will be the variable manipulation element, because the displacement of this mechanical linkage is converted or amplified into a large angle, so that the pointer rotates with the help of this gearing mechanism. So, the gearing mechanism which amplify the small displacement and makes the pointer to rotate through a large angle acts as the variable manipulation element. Finally, the data presentation element, which is nothing but the pointer and dial, which indicates the quantity to be measured, which is nothing but the input pressure. So, in this class we have seen the generalized block diagram for a measuring system, which has its own necessary functional elements and their functions, but the functional elements may vary according to the quantity to be measured and the instrument which is used for measurement. Thank you.